Let's start off with a small activity. Please take 10 seconds to skim through this article. All right. Hi, everyone. My name is Nguyen, and I am a fourth-year PhD student at Carnegie Mellon University. Today, I'd like to talk about a series of studies showing that round numbers can sharpen cognition. This work is done in collaboration with Hofman and Dan Goldstein from Microsoft Research. So we consume a large amount of information every day, over an average of 7.5 hours, from TV, social media, and web browsing. Among these different sources, numbers show up a lot. While numbers are useful, they may not be the most friendly to us. Let's use the article earlier as an example. Think for a moment about whether you have the answer to these three questions. How many transfer students applied to the UC campus? How many were accepted? And what was the acceptance rate? Were you able to recall these numbers accurately? Clearly, it's not easy, and it becomes even more difficult if you read the article, say, 2 days ago instead of just a minute ago. So the question we want to explore is, how do we help people better recall and make use of numerical data that they see in the news? This is actually a very relevant topic to the SCI community. For example, prior work has shown that using perspective sentences, which re-expresses an unknown quantity in terms of more familiar values, can help people remember the numbers they have read. Alternatively, decreasing the visual quality, making the numbers more difficult to read, can increase the processing effort and, in turn, the likelihood of correctly remembering the numbers. In this work, we want to take a different approach by focusing on the number representation itself. In particular, we want to see whether the effect of simply rounding the numbers is beneficial, given that round numbers are easier to process, but also less precise. So our question is whether decreasing the precision of information shown to people can increase their accuracy on cognitive tasks. And if so, can we leverage these insights to build an intelligent interface for number comprehension? To address this question, we conduct a series of 3 studies. In our first study, we have the participants do basically what you did at the beginning. They were assigned to either the precise or the round condition, and they started by reading 3 new articles, each with 2 focal numbers. The only difference is that in the round condition, the focal numbers are rounded to 1 leading digit, as you can see here. Participants were then asked to recall the focal numbers from the readings. So here's the task interface where we show the article again, but with the focal numbers omitted, and participants had to fill in the blanks below. We consider a response as approximately correct if it is within 10% of the precise number. And we know that this applies to both conditions. So even the round condition participants need to be within 10% of the precise number, even though they did not see that number in their readings. Then in the estimating task, we ask participants to perform a simple estimation based on the 2 focal numbers that they recall. In this example, they are estimating the division of those 2 numbers. Similar to the recall task, we also consider a response as approximately correct if it is within 10% of the estimation obtained from the precise version of the numbers. This again applies to both conditions. So here's the flowchart of our overall experiment. We recruited 1,300 participants from Amazon Mechanical Turk and randomly assigned them to either the precise or the round condition. With regards to our findings, for the recall task, this plot here shows the sample mean and standard error of the proportion of accurate responses across all the recall questions in each condition. We see a large difference where those in the round condition were accurate for about 20% of the times, more than those in the precise condition, despite never having seen the precise number. For the estimation task, we again see that people in the round condition were correct for about 30% of the times, more than those in the precise condition. So the key takeaway here is that round numbers can lead to more accurate recall and estimation. This brings up an interesting trade-off where if people only see round numbers, then they lose some precision initially because of the rounding. But when they have to recall or make estimation with these numbers, they are able to do it much more accurately. So we know round numbers are helpful, but that doesn't mean we should round everything. That's still the question of how much rounding is desirable and whether this depends on the context of the information. To address this question, we conducted a survey consisting of 15 tasks. In each task, we give participants a short news quote about a particular topic and contains a random precise number. Then we ask them about how much rounding is suitable in this context. Here is an example interface. We show the news quote at the top with a random number of length 7. Then we present all rounding options for this number, ranging from no rounding to rounding to one leading digit. And we ask people to rate each option as either too precise, looks good, or too round. What we found from the survey is that the majority of responses consider number with 2 to 3 leading digits to be looking good, in that they are not too precise and not too round. Furthermore, this pattern doesn't seem to change based on the news topic. So it was surprising to us that people would say a 10-digit number rounded to 2 digits is acceptable, because that is a lot of rounding. Our hypothesis is that people are used to seeing only 1 or 2 decimal digits, so they treat the thousand and subsequent digits as insignificant. In other words, they could potentially say 1.23 billion looks good, because 1.23 looks good. In that case, what would happen if we fully wrote out the rounded numbers instead of using modifiers? So we conducted another survey to explore this question. The setting here is identical to survey 1, except that we no longer use decimal notation and modifiers for large numbers. We indeed found that there's no longer a convergence at 2 to 3 leading digits. Instead, people prefer more precision with larger numbers. If we look at where people start to say a rounding option is too round rather than looking good, in other words, the minimum acceptable precision level, we also see a proper linear relationship where more precision is required for longer numbers. So in summary, we found that seeing round numbers provides more cognitive advantage for recalling and estimating than seeing precise numbers. In addition, people prefer more rounding up to 100 times when numbers are expressed with digits only than with decimals and modifiers. Based on these insights, we have developed a prototype browser plugin that can automatically detect numerical data in the document and suggest appropriate rounding options in order to enhance the user's information consumption. More information about this tool can be found in the GitHub repository for our paper. And that concludes our presentation. Thank you for your attention.